welcome. This is Bootstrapping Made Easy. My name is Matt Ullmer. I'm a DBA with Yelp. And I'm going to be talking to you a little bit about our stuff. But first, Yelp's mission is to connect people with great local businesses. And who we are. We have 4 DBAs at Yelp. We have Jenny, our manager, Patrick, Susanna, and myself. We manage hundreds of servers. We are fully managing, configuring, and maintaining everything ourselves. We don't depend on any SREs for any of our stuff. We run Percona Server 5.6 and Ubuntu 14.04, codename Trusty. And so the 3 main things I'm going to be talking about are a little bit of the basics about what we do and what we have in our architecture, the goals of our infrastructure, and how we glued everything together to help make the bootstrapping process easy, and how we did this with largely open source tools. We didn't just pay to win, or we're not offering anything pay to win. This is kind of pieces you can put together yourselves based on your use case. And what this gains for bootstrapping and how it makes it easy from a DBA perspective. That's effectively what I'm going to be talking about here. And so we are a typical LAMP stack. Linux is Ubuntu, we have Apache, we have MySQL, and we use Python, not PHP, in our LAMP stack. And so in the typical journey of a company going from startup to more of a robust, like growing company, you will eventually need to come to the decision of scaling out and how you do that. So you'll go from having just a single database cluster to having many co-located schemas or many individual clusters that have one schema in them. You'll have no longer just a monolithic service. That's kind of Yelp's journey. We started with a monolithic service, and we went into more SOA services, many services in general. But you're going to find that there's a lot of manual effort if you don't automate a lot of your stuff. So your infrastructure will need to expand from having just a couple of database hosts to a few dozen webs, and later you're going to have dozens or hundreds, and you're not going to want to do this by yourself as a DBA. Your tools must compensate for having many clusters. You'll have to break hosts down into roles, into clusters, spread them for disaster recovery, and manually enforcing a lot of this stuff will require a lot of effort. So also, you have to consider that you're going to be probably going to multiple data stores because you're not going to find that MySQL or Postgres fits every use case. So you're going to want to think about this and think forward, because as the responsibilities of DBAs expand, you're going to have a hard time keeping up with all of that additional workload and continue to be impactful as engineers. And so then it comes to when do you automate? And so in order to properly scale out and appropriately constrain costs, you need to automate. And you can only hand curate topology or service discovery, whatever you want to call it, hand roll your database machines, or babysit hardware for so long before it becomes the majority of what you do. And so you need to automate to free up time to do new, awesome things. And I'm not going to talk to you about just pay for this one thing and your problems go away. I'm going to talk about how we've pieced together various open source technologies and how we've glued everything together in order to make our infrastructure actually work and do the work for us so that we can do more cool things. And so that's what this whole next section is about, tying it all together. And so first, just a little bit more about our high-level goals here. We want a system that will scale itself given a high-level command of give me more of X or a schedule. We want a system that takes the human out of the rest of the deployment process and just puts the host into use. You don't want to have to sit there and wait to hit the button when the host is ready, or go and make sure the host has reached all of its critical checkpoints in its launching process. A system that tests itself so that you know with certainty that what is needed, that when it is needed, it will work as designed. And all of this kind of combines to build a system that is self-healing. And that's the important goal here. And so kind of an example here, if you lost a host in a major cluster, it will automatically remove itself from usage. It will minimize the application errors by doing that, and it will launch a replacement. And when it's ready, the host will warm itself up and put itself back into service. And so you don't really have to wake up a DBA at 3 a.m. to fix the problem or push the button. It'll solve itself. And so we've kind of broken this down into this glue section into 4 major pieces that we consider to be bootstrapping. So the first is we need to advertise a host. Specifically, this is like a MySQL implementation of this. We need to advertise a host as healthy and ready to bootstrap from. We need to stream the backup in real time with minimal impact on our environment. We need a standardized way of maintaining our replication hierarchy. And we need to be able to automatically add the hosts into usage for the service discovery. And the first step that I'm going to talk about is having the ability to pick a source host. And the 3 main pieces of this task are being able to identify the host in the right database cluster and to pick a valid role to bootstrap from. Then we need to build a snapshot server that can encrypt and stream the extra backup data. And we need to advertise the snapshot server via Smart Stack based on cluster and role to allow extra backup to stream the data. I'm going to talk about the Smart Stack stuff a little bit later. So the first section of this is we use Puppet, and this is how we kind of configure clusters and roles. For this given example, you have the main and monitoring clusters. Those are just arbitrary clusters. They're really named anything you want. And so we configure those database clusters in Puppet, and they have facts that identify them. And so a host could be either in the main cluster or in the monitoring cluster. They can't be in both. And they have, in our default configuration, 3 possible roles. They have the master role or writable role. They have the reporting role, which is kind of read-only, but less efficient, longer running queries. And the read role, which primarily runs like the normal standard select queries that serve the website. And this is an example of how we've implemented it in Puppet Hira YAML syntax. So valid roles here are master, read, and reporting. We also have the idea of valid backup roles here. And so if we don't allow all of the valid roles to be a backup host, then you would not be able to restore from, say, a master host if it wasn't in the backup roles section there. And we also define for alerting purposes the master, read, and reporting configuration that we use in Sensu to determine that each host is configured correctly. And another section of this that's very important is how we classify environments. We have a hierarchy that is kind of 4 levels. We have an ecosystem, a superregion, a region, and a habitat. Ecosystems are made up of superregions, which are made up of local geographic regions, which are made up of habitats. A habitat you can consider in Amazon to be like an availability zone. A region is synonymous with the orange circles on the Amazon global infrastructure there. And a superregion is more like if you have a physical data center and an Amazon data center within 100 miles of each other, that's probably like one geographic region. And that would be a super region here. And then ecosystems are pretty standard, prod, stage dev, that sort of thing. The next section I'm talking about is snapshot server. And so first I'll kind of describe how it works. And then I'm going to show you the code that actually does all the same stuff in Python. On the next slide. So the fundamentals of it, it binds itself to a port. It receives, any received connection will trigger a compare of the cluster coming in to the cluster the host is, verify they're the same, because you don't want to restore like a main cluster host from a monitoring host. That wouldn't make any sense. It's nice so that we don't have heavy load on the host, because we run all of our hosts serving production traffic while they're doing these streaming processes. We also use filler packets to not interfere with the running database network traffic, so they're just lower priority, and if they're dropped, it's fine. We don't want to like cause the host to throttle some of the real traffic that we actually want to serve. Then we have extra backup to stream, which is something I'm going to talk about a little bit later. That is how we actually do the streaming process through the snapshot server. The stream itself is encrypted with Amazon KMS, and we either allow or disallow backups on a particular role, as I mentioned earlier, and all that is controlled within Puppet. That is not supposed to be. Sorry, I just got to pop up on my computer. So this is the actual code itself. So it's pretty much line by line kind of what I was saying. So cluster name is the check there. The NICE is on the OS. The socket priority is lower. And then extra backup to stream on port 3306. And so it's pretty self-explanatory. I removed all of the comments that actually Josh wrote a few years ago. All right, and so now how do we actually advertise this as being available for a particular host to bootstrap from? And that is with SmartStack. It's a little bit deep to get totally into it, so I'm going to kind of describe the basic fundamentals, and if you want to know more, Suzanne is actually talking about service discovery and SmartStack later today at 350 in Ballroom D. But the fundamentals, it consists of Nerve, Synapse, and Zookeeper. And so Nerve is used to do health checking. Synapse reads Zookeeper for available backends and uses that information to configure a local HA proxy. And the infrastructure is completely distributed. Zookeeper is the most critical set of nodes. And it's specifically designed to be distributed and robust against failure. So within a given health check that Nerve runs, delay of a backend becoming healthy. So Nerve determines the backends become healthy. It will let Zookeeper know that is healthy. Synapse will pull that down, configure the local HA proxy, and now it's being advertised as available as that snapshot server is now available to be bootstrapped from. Next section is actually pulling a backup in real time. We consider our backup infrastructure as a whole to be three parts. The backups themselves and how they're done. Backup testing to verify that they're actually restorable, and streaming, the mechanism with which we stream a backup to a new host. So first, if you're familiar with MySQL, you're probably familiar with extra backup. I'm not going to go too much into it, how it works, but it's low impact. We can compress it. It allows us to do streaming. We do encryption externally with GPG, and we also offsite to S3. And this is the basics of our implementation of a static daily backup that we do. Our wrapper script executes the innobackupx script with our preferences, basically evaluates what you see under wrapping innobackupx on the screen. And all of the parameters are configurable based on the machine size and capability. We use Puppet facts to then do math and come up with like the number of parallel threads for pigs or parallel for the extra backup itself. And we run our backups on, or we load the backup to an EBS volume so that on live hosts, so we don't like use the I/O on the actual live SSDs that we're running everything on. And we don't want to have any underutilized hosts, as I mentioned before. So every host that we have that is running a backup is actually serving traffic for the website. They're not isolated or standalone backup hosts. And so this is two parts. And we just have cron tabs on there that do a local backup and then offsite to S3. The next section is backup testing. And it's one thing that many organizations actually forget to do until they absolutely need it. And you never want to be in that situation. So if you don't actually test your backups and then you need it and it doesn't work, you're kind of in a bad spot. And sometimes this might drift. So if you don't do this regularly or automatically, you're going to find yourself, in that bad spot and be unaware. So the way we do this is we scan for backups, we restore them, and then we verify that they're restorable. So we kind of write back, and we use S3 as our durable store for this. So we scan the daily static backups that are all in S3. We restore one at a time forever. So like if we have 20 backups for 20 different clusters, it'll find the most recent one for each of them. It'll pull it down, it'll restore it, it'll write back that it was restored and is verified. And then I'll move on to the next one, and I'll just go in a loop. And if it doesn't find one, it'll wait 5 minutes and check again. So the restore is considered complete when a database comes up without error, and we're able to query it. That's kind of like the basics of how you verify something can be restored. And then we tear it down. We write out the log, verified failed status to S3. We additionally have an alert that an offsite backup has been successfully restored within the last 3 days. So if it does start failing, it has a few days to attempt to recover. And if it doesn't recover, then we do, page the DBAs, hopefully during the day. And then streaming, the actual Bootstrap itself. We've had talks about this before at Percona Live. I think Josh actually gave it in 2014 when we first wrote just the plain Bootstrap process itself. And all of that is the basis for the current and future work of tying all this together. And this is some history, a really janky piped script that we ran, and this is the first stream we ever did. It's a little hard to read. I'll touch on some of the important parts. Anecdotally, no version check is here because CentOS 5 would fail if you tried to check the version on it with extra backup. So we have no version check in there for that. Slave info is important so that we can actually restore to the master of the host we backed up from. Pigs is parallel gzip. Here we're using 10 threads. No math was done to determine that. We just said that 10 threads are good. We capture all of the output of extra backup in extrabackup.air, and we visualize everything with PV. And now kind of how we do that in a more modern world is extra backup to stream, which is an automated version of the previous streaming. It's advertised with the snapshot server, and you saw how it was called. Basically, we use, again, SmartStack for discovery, the snapshot server to make it visible, role checks to allow or disallow the bootstrapping, and extra backup to stream to actually do the real extra backup. And this is the base of extra backup to stream. Don't worry about copying anything down. I will put the slides on this, I promise, and they will upload it somewhere. And so this is basically all of the same stuff in the inner stanza there for InnoBackupX that was in the previous janky version, but it is actually done with math. So parallel 8 was actually determined based on the number of cores available on the host that we deployed this to. And the rest of it is kind of just like streaming it and where to stream it. And we're also gathering the return code to verify that it did complete 100%. And we're storing the output of extra backup. Instead of extra backup.error, it's now stored in the standard error. So it actually makes a lot more sense for Linux people. And what you get when you run all of this is you get basically this output in the log file for the Bootstrap. So it'll say connecting to snapshot server and on whatever IP and unpacking backup. And now I'm going to talk about reparenting to an intermediate master database. But first, we probably want to know what an intermediate master database is. I don't know that everybody uses this in their infrastructure. And one key feature is how we do this. And so what is it? These are hosts that we nominate into a role for bandwidth consideration. So for instance, if you have 10 hosts in US East and 10 hosts in US West, you don't want them all replicating from the master database for bandwidth purposes. So if you elect one in US East to be the main replica and all of its buddies are replicating from it, then you only have one stream of bandwidth across the country. Also for disaster recovery, so if you have, like in a simple replication hierarchy, you have a master and 3 replicas. If the master goes away, you don't know which of the replicas might be the most advanced, and so you would have to actually look at all of the binary logs to find the most advanced one, elect that as master, reparent everything else. And we also, to enforce this kind of replication hierarchy, we have automatic reparenting on Bootstrap so that it will bootstrap from a leaf node and then reparent itself to the intermediate master. And we specifically do not bootstrap from the intermediate master because if you have an intermediate master that already has 20 replicas, it's already doing substantial I/O, and an extra backup is significant I/O as well, and you might actually impact the server. While a leaf node is doing far less I/O because it's not distributing binary logs to every host. And since we don't bootstrap from the intermediate master, but we want to ensure that the leaf nodes replicate from it, we do have to have that little logic here. And like we do not use GTIDs yet because the deployment of that in a very large deployment of MySQL is a little bit complicated. It requires you to take everything down, bring it back up. Won't go into that here. But in any case, we continue to use statement and in some cases row-based replication, and we don't have GTID. So there's no like auto reparent equals 1 or whatever. That doesn't work for us. So we have an internal tool that automates binary log matching over like prescribed window. Pretty generic. It just kind of takes the manual effort of comparing visually binary logs and matching windows yourself out of the picture. So the tool is used in conjunction with downtiming of our Sensu alerting. We don't use Nagios, we use Sensu to do all of our alerts. And so we use that, we downtime, we reparent, and then when all of the alerts go green, we put it into service. This is fully automated. And so effectively, this is what you see when a MySQL instance becomes healthy and reparents itself. So it comes up at 11:23, and then at 11:30, after it's fully caught up in replication, it determines who the intermediate master is, and it reparents itself, and this is what's written to the log file. And the final part of the glue here is service discovery. Service discovery has a few parts. Start with health checking. So if a host dies, do you automatically recover? Do you remove it from your service discovery system? Do you send alerts to your DBA? Or do you have automated processes in place to take care of it? And so for the health checks themselves, we actually use HACheck. We check HTTP, TCP port, and some MySQL stuff. We have future things in mind there that aren't currently implemented, like to check the heartbeat of the host, make sure it's actually caught up in replication, to have limits on when a host is marked unhealthy so we don't drop everything out of our load balancer. And then we use all of that to kind of power auto topology, which is our name for service discovery basically internally, and how we distribute the connection information to all of our hosts. And we use a service to watch and return smart stack advertisements from every habitat and generate the topology based on real-time information. We call this service the discovery service. Real unique name there. But when a host comes up and passes health checks, we just add it to topology with Jenkins. And now actually joining the load balancer, because we have the topology files being automatically generated, all we need to do is to establish conditions under which they'll be automatically deployed. So protections for dropping everything out, we don't want that to happen, and validation that the host is actually ready to take traffic to put it in. We use Jenkins for all of that as well. So that's kind of all of the glue. And now you might be wondering, how does this make things easy? And it's best to do this with an example. And so let's say we add a new data center, and I'm going to kind of obfuscate all the stuff away that an SRE or another team might build, like the VPC or the app or web layer, building the external load balancing or memcache or whatever other infrastructure you require to actually serve your data out. And so that's kind of the global expansion, adding a new data center. And there's three main aspects to this. One, how do you discover them? So in SmartStack, typically you don't want to just kind of set it up to advertise every availability zone or habitat everywhere. That's a heavy amount of load on Zookeeper. So you actually constrain it by default to be habitat level or region level, and usually not higher than that. Otherwise, you have extreme load on Zookeeper and you might have instability. And so for discovery, that's important. I'll talk about that next. But remember, we do have Snapshot Server, but it's not by default generally available everywhere. Second, how do you launch the databases? We have a recommendation. Everybody does it a little bit different, but we like the way we do it now. And then how do you add them to the load balancer in adding a new region? So again, in SmartStack configuration for Snapshot Server, you can advertise into a new region. So this is the main cluster. You're extra advertising the existing region into a new region. So old region to new region there. Otherwise, you won't actually be able to see it. And once you start doing this, you kind of unlock automatic bootstrapping in the new region. So if you had US West 1 as your old region and US East 1 is your new region, now when you launch a host in US East 1, it'll just automatically see, hey, that snapshot server is ready, it's in my cluster, and it'll start bootstrapping. Might be a little bit slower because it's cross-country, but you're going to be a little bit slower no matter what you do, and this kind of takes the human effort out of it. It just does it for you. But how do you actually launch your databases is the next important section here. In the old manual world, you'd have to copy a backup or manually stream data by triggering a backup yourself. You'd need to hand curate, change DNS or some other manner to actually launch the host. You'd have to name it. You'd have to put it into the load balancer yourself. But we want to take the manual effort completely out. And so our recommendation is no host is special. Don't name your hosts. This leads to like a special attachment. They're not cattle, or they are cattle, they're not pets. You should come to expect your host to go away spontaneously, especially in the cloud. Like when you're in the cloud, Amazon could pull your instance from you at any time. Google, same thing. Other cloud providers, same thing. And so a great step forward is launching your host with ephemeral names via an Amazon ASG or auto scaling group. You can define, I want 3 main cluster hosts in this region configured this way. You can also use Terraform to do this with code, so you don't have to ever log into the console. You can schedule hosts to come up and track your traffic through the day and tear them down when traffic diminishes. So if you need an extra 2 hosts from 9 a.m. to 3 p.m., then you can launch them an hour ahead at a time or an hour after you're done using them. You can save a bunch of money that way. And they'll receive their role and cluster normally as configured with Puppet. No special human intervention required. And then how do you do service discovery? Again, with the discovery service, we automatically detect any new hosts in a new region and add them to our topology. So DBAs simply add the region to Terraform, topology regeneration runs automatically, and the databases appear without any additional effort once they pass all their health checks and are up. We have alerting on every phase of the process, so we understand and know when a problem requires human intervention. So there's no GUIs, there's no enterprise tool that you download and use. It's just command line introspection. If a host fails because Amazon pulled it for a failure, the same mechanisms will recover the cluster. So Jenkins builds a new topology, Jenkins checks the topology is valid, and Jenkins pushes it out to all services. There it is. And that's all I got. But before we go to questions, again, got to plug my colleagues a little bit. Susanna's talking in Ballroom D at 3:50 today, and Patrick is talking about Postgres to MySQL transition, his personal journey as he went from being a Postgres DBA to a MySQL DBA and the things that he learned, and compare and contrast the different data stores in Ballroom G tomorrow at 1 o'clock. Jenny is just being cool.
And having her work called Jakey.
I think Josh and I were equally responsible for the jankiness of that. And obligatory slide, we are hiring. If anybody likes the sound of anything that I talked about, then please come talk to us at our booth or after the talk. And any questions, I am available.
Sounds like you guys mostly run on AWS then?
We're actually mixed between physical data centers right now and Amazon.
Are there any kind of challenges you guys have hit either with one or the other that kind of causes more issues for the DBA team?
It's a lot easier to use all of the Amazon experience that we have garnered as like the greater operations team and DBA team in launching new machines there over the very infrequent launching of physical racks and things. So in general, I think we've benefited from having fast fail Amazon stuff causing, like if If it hurts, do it more. Our machines fail. We deal with it. We're getting more fast with that, and this has helped with this journey.
You mentioned verify as a step in backups.
Yep.
But did I understand correctly, verification simply consists of essentially a select one or something after it comes up?
So I guess I should repeat the question. How do we verify a backup in our backup testing is effectively the question. And what we do is we will actually restore the database fully. So we actually look at the output of extra backup restore. And then when the database host comes up, we'll actually query like the heartbeat table and verify that the data there is sensible. So it's not just like a select one. We actually do like a real query against a real table that would have data.
How did you go about selecting an automation tool? How do you go about not using Ansible?
So how do we determine the configuration management tool that we use? So that decision actually predates me at Yelp. So it's well over 4 years old. But we have a lot of experts in Puppet, people that have spoken at conferences. So that definitely played into it. It's one of our main expertise. And it's very dynamic as Puppet has evolved as a configuration management tool. We've unlocked a lot of interesting mechanisms on how to manage and configure hosts that make it so that we aren't repeating ourselves at any point in the code base. So like if you find yourself defining things multiple times, you're probably doing something wrong. And so that's kind of a loaded question, and going into that really deeply will probably take a long time, but I'm happy to talk to you like after. Any other questions? All right.